Hello everyone. Thank you very much for the introduction. My presentation is about MTG Li level 2 accumulated products. We work together with Catalina and Alina too, and I will present you the content of this presentation. So we have the introduction. We will talk a little bit about Lightning, Met 12, it's the instrument. We have the data and the prototype code, the level 2 data that we will analyze. So we have accumulated flashes, accumulated flash radiance, and we'll talk a little bit about the prototype. We will talk about the results and what we have until now in the data book in Python and the conclusion of the chapter. So the linings, I think that everyone knows about it, but I'm not sure if a lot of you know about how it's made, and there are some different kind of groups. And as you can see in the figure 1, we need different kind of components like the positive electric charge, like the negative. And in the same time, we have 3 main groups. We have the cloud to ground, cloud to cloud, and the intra-cloud. So the linings with all the advancement of the technology and observation systems are can be forecast, and we can forecast the intensity lining activity, but at the same time, it is impossible to predict every lining strike because this phenomenon can be frequent and unpredictable. So because the lining is associated with storms, which can bring extreme weather such as torrential rain, hail that we have experienced more in this part of the year, the strong winds and the tornadoes, it holds great importance in meteorology. But in the same time, we can offer different kind of information about the atmospheric chemistry, being based on the fact that after aligning, we can know more about the atmospheric composition and also the pollution, because after aligning, the nitrogen dioxide can be produced and can contribute to the tropospheric around level ozone information and affect the air quality too. So lining detection systems supply near real-time data and are then finished with the weather forecasting models. In the same time, we can follow the storm life cycle from the formation to dissipation. So we'll talk more about the satellite, the MT-12 and its instrument. So this satellite is the first one that has been launched in 2022 of the third generation of Meteosat satellites, and is located at 0-degree longitude and have the ability to monitor over Europe, Africa, Middle East, and part of South America, and as part of the surrounding waters. You have in the figure on the first image of the complete Earth disk taken by MT-12. In the same time, can offer principal instrument is a flexible combined imager FCI that offers essential roles in providing more accurate information about the volcanic ash, about the fog, the air mass characteristics, aerosol, wildfires, and clouds. In the same time, has the spectral ranges covering visible to infrared wavelength, and at every 10 minutes will provide an information. The spectral channels visible 0.6, near 2.2, and the IR 3.8 and the IR 10.5 are derived in normal and high resolution. Okay, so we'll talk more about the lining imager, that is our interesting instrument. So this is the first instrument that had been launched by the European, it's a European instrument. It's the third one that has been launched by this kind of to monitor the linings. The first one was launched by the USA, the second one by the China, and this is the first one that has been launched by the Europe. So we will have an 100% of the states member of the UMETAT. And in the same time, this instrument, it's include 4 identical optical cameras, each with different kind of characteristics. In the same time, the narrow band filter center over the neutral oxygen triplet is at 77.4 nanometers with 1.9 nanometers bandwidth. In the same time, the spatial resolution subsatellite point is of 4.5 kilometers. And for Europe, will increase to up to 10 kilometers. That's why we are working in the same time as a parallax correction to reduce as much as possible this kind of limitation that this kind of instrument has. So in the figures 4 and 5, we have the 3D representation of the lining imager instrument. So we will talk a bit more about the data and the prototype code. We have the types of data. We have also level 1 and the level 2 are of interest for us. We have the lining flashes, LFL, also for this kind of data. Eugen also use it for the lining jump. That it's very useful in seeing how a storm can be or not severe and start to be more dangerous, let's say like that. Lining groups, and for this, what I have studied is about the cumulative flash area alpha that provides information about the area covered by the optical emission of each lining strike. We have the accumulated flashes. It's complement the alpha by providing information about the variation in the number of events. In the same time, we have information about the pixel by pixel variation of accumulated optical emissions provided by accumulation flash radiance. Here we have the graphical representation of each of these data. So the data use it for this for our interested are the 21 files per cycle for alpha, AF, and AFR. In the same time, it was we tried to have the same time for FCI and the lining. That's why the LI level 2 accumulated products are for 10 minutes. As you can see in the figure 9, that why we wanted to have this to have it accumulated for 10 minutes, because we wanted, because of the fact that we have the for FCI spatial resolution subsatellite point of 2 kilometers. For LI, it's of 4.5 kilometers, and this kind of accumulated flash radiance are regridded on the grid FCI grid. So the prototype code is in C. It's a C programming language. So we have different kinds of advantages and disadvantages in working with this language, because in the main limitation was the fact we needed to include this part of the lining on the big picture, because this code, the main code was wrote like, I don't know, 28 years ago. So we needed to include this part too for the lining to ensure the continuity of this. So for this part, we have the main stages of the program execution. We have reading the files, initiate the variables, reading input files, data accumulation, and also now we have the parallel correction, writing output files, and the free memory. In the state and advantages, ensure increased control over the process data, allows efficient resource management and optimization of the workflow. In the same time, high complexity, strict requirements, and the need for a meticulous approach, as the programmer must have deep understanding of both memory and allocation and its manipulation, was the biggest disadvantage. So we need to work with this library, MWC library, that is the specialized library developed as part of the NWCSAF satellite application facility. And in the same time, we needed to, the results obtained is an SCDF file and contain a two-dimensional matrix. I wanted to mention that the level 2 data that I have explaining some slides ago are 1D dimension, and we needed to make it 2-dimension at the same time to accumulate it, to make the parallax correction because we have a difference over the Europe. And so the main function used is for allocating to the matrix of flow to free the memory in the same time. These are the specialized function in the NWC library. We need to create some of it, like rotate matrix, in order to maintain the continuity and to include all the parts. So I will show you some of the results. So this animation shows a view of the MET12 LI covering about 84% of the visible disk. The intertropical convergence zone is characterized by continuous lining activity located to the north of the equator and the equator. The formation and the westward movement of a large long-lived thunderstorm cluster or mesoscale convecting system can be seen. The video demonstrates that LI can detect thunderstorm very close to the edge of view in South America. This animation was made using 2 hours worth of accumulation flash area AFA, and for the 5 October 5, 2024. We also have an animation over the Europe, and also you can see this spatial resolution of 10 kilometers that it's more visible for this part because called the field of view and so on. So for Romania, we have a comparison and an evolution of time of the intense convective and lining activity above the southern part of Europe. The drop in several pressure levels and the presence of humidity led to increased atmospheric instability. During this period, there was significant precipitation accumulation, which was particularly evident in Romania. We also have, let's say, an evolution or time evolution or in at 20 minutes, 40, and so on, like the previous figure. So we compare the results obtaining with the data from Romanian ground-based lining location network for the same day. So here we have another day. It's for September 24 for a different time slots. And in the same time for the Europe as a zoom to put more in evidence that we have some the spatial resolution is still a problem. So here we have what we have implemented in Python also, and this is the prototype that have been already implemented in European Weather Cloud. This prototype don't have the parallels correction and can be available by accessing other group viewer. So if someone interested in expand its knowledge on this part, you can have a look of this. We have the accumulated lining if you press on the XP. So here we have all the data. Right now it's a modification, so we have 10 minutes for each of it. You can add it and you can see its evolution if you wanted to, I don't know, analyze something and for each data you can have for 5 days. So this is right now. And also we have different kind of products for NWC for the geo part. You have here if you want to know more and to analyze more. Thank you very much.